Welcome to Wow DIY. Today we are going to do some cool chromatography experiments. Chromatography is a technique scientists use to separate mixtures. In most cases, it involves a liquid, called the mobile phase, and a porous solid, called the stationary phase. As the mobile phase moves through the structure of the stationary phase, it pulls elements of the mixture along with it. Some parts dissolve in the mobile phase better than others. This is called solubility. Since the components of the mixture interact with these phases in different ways, they will travel through the stationary phase at different rates, leading to separation. Capillary action, or the ability of a liquid to flow in narrow spaces without the assistance of an external force, powers the following chromatography experiments. We will do two activities to observe the power of capillary action. First, let's try to separate the components of black ink. Ask an adult to help you gather the following supplies. You will need white construction paper, popsicle sticks, a ruler, a measuring cup, vinegar, rubbing alcohol, water, 2 large clear cups, and a black marker. A small binder clip can also come in handy. Now it's time to experiment. Begin by cutting white construction paper into 1-inch strips. Make a thick line and black marker about 1 inch up from the bottom of your strip. Mix your solvents consisting of equal amounts of vinegar, rubbing alcohol, and water in one of your cups. Pour a small amount of this mixture into the bottom of your other cup. Make it less than 1 inch deep. Suspend the strips in the glass by wrapping the non-inked end around the popsicle stick. You can secure it with a binder clip. Then submerge the bottom of your strip of paper in the solvent. Make sure the liquid is below the line you drew. Allow the paper to soak up the solvent and watch what happens. As the liquid moves up through the paper, notice that the more soluble components of the ink will move faster and end up near the top. Less soluble components will move slower and remain closer to the bottom. Changing the components of the solvent, for example, adding more vinegar or using less alcohol, will change the solubility of the ink components and therefore change where they migrate on the paper. For more fun, try to test different color markers. Let's do another experiment. Typically, plants pull water from the ground, but have you ever wondered how? Water moves through the plant via capillary action. The plant sucks water up its stem, much like a straw. The water then evaporates out of the leaves and petals. As the water evaporates, it pulls more water up the stem in a continuous cycle. Have an adult help you collect the following supplies. I recommend a white carnation, but other flowers with white petals will work too. For best results, call your flower shop and ask them when the flowers you want will be delivered. Flowers are transported in a slightly dehydrated and cooled state. Prior to sale, they are rehydrated. You want a thirsty flower and will observe the fastest results if you get a flower that has not yet been allowed to drink. You will also need scissors, food coloring, and a glass of water. Now, fill the glass halfway with water. Since I am making orange, I will use 8 to 10 drops of red food coloring and 8 to 10 drops of yellow food coloring. You want to make sure your dye is really concentrated. Swirl the glass to mix it in. Cut the end of the stem off diagonally to a height that will allow the flower to rest easily in your glass. Be careful using the scissors. You may need adult assistance. Safety first. Leave the flower in the water and observe the petals over a period of a few days. Take notes. We set up a camera to track our flower's progress. Check out the results. As the water travels up the stem of a flower, it pulls up nutrients. We are modeling this process. Like in our first experiment, the dye molecules traveled at different rates. Notice the yellow dye appears first. This time lapse allows us to see the components of the orange food coloring separate and eventually recombine. Try other color mixtures and see what happens. These activities take patience, but both give very satisfying results. Remember to clean up all of your supplies when you're done. To learn more, search terms like paper chromatography, thin layer chromatography, capillary action, solubility, transpiration, adhesion, cohesion, and surface tension. For more fun DIY activities, visit us at wpafbstem.com. Thanks again for joining me, and I'll see you next time.